Ethereum is actually migrating to what we call proof of stake. So instead of spending a lot of electricity, what you're doing is that you're instead locking up a lot of Ether. You're locking up a lot of this cryptocurrency called ETH. And basically, to participate in consensus, you need to put that up for stake. If you do anything malicious, you can start losing that stake. It changes the paradigm, right? You don't need this crazy computational thing. Anyone can run it on a home server. You can run it on consumer laptop. Since Ethereum was already proof of work, the transition into proof of stake, it's very solid because we can leverage all the security that Ethereum has already over the years into this new paradigm. So we are one of the teams that's building proof of stake for Ethereum. Proof of work, the mining basically, is planned to go away in less than a year. So no more shortage of GPUs on the market. You'll be seeing a lot of really cool stuff happening. Estimated, I believe, to be like 99.98% more like computationally effective and like better for the environment. So that's something we're excited about, and just keep an eye out on that.
Big thanks to our partners Linode, Fastly, and LaunchDarkly. We love Linode. They keep it fast and simple. Check them out at linode.com/changelog. Our bandwidth is provided by Fastly. Learn more at fastly.com and get your feature flags powered by LaunchDarkly. Get a demo at launchdarkly.com. This episode is brought to you by our friends at O'Reilly. Many of you know O'Reilly for their animal tech books and their conferences, but you may not know they have an online learning platform as well. The platform has all their books, all their videos, and all their conference talks. Plus, you can learn by doing with live online training courses and virtual conferences, certification practice exams, and interactive sandboxes and scenarios to practice coding alongside what you're learning. They cover a ton of technology topics: machine learning, AI, programming languages, DevOps, data science, cloud, containers, security, and even soft skills like business management and presentation skills. You name it, it is all in there. If you need to keep your team or yourself up to speed on their tech skills, then check out O'Reilly's online learning platform. Learn more and keep your team skills sharp at O'Reilly.com/changelog. Again, O'Reilly.com/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. We have some awesome episodes lined up for you. Battlesnake, a live show from GopherCon Europe, a deep dive on the V2 Plus issue, and the hotly anticipated debate, do devs need a product manager? Subscribe now so you don't miss it at gotime.fm or simply search for Go Time in your favorite podcast app. You'll find us. Okay, here we go.
Hello and welcome to Go Time. In this episode, we're going to be talking about building for blockchain in Go. And we're joined by two of the co-founders of Prismatic Labs, which is a company behind the upgrades to the Ethereum network. We have Raoul Jordan and Preston Van Loon, who will be talking about how they started the company, as well as what it's like to build technical infrastructure for the Ethereum blockchain using Go. So today, Prismatic Labs maintains the most popular implementation of Ethereum proof of stake, running a network of over $15 billion. So let's introduce our wonderful guests. First of all, we have Raoul Jordan, whose pronouns are he, him. Raoul was born and raised in Honduras and came to the US for university to study computer science. He then dropped out of college after receiving the Thiel Fellowship. In 2017, he discovered Ethereum, which felt to him like taking a time machine to the year 3000, and he knew this was what he had to be working on. A little fun fact about Raoul: he speaks Cantonese and practices Chinese calligraphy in his spare time. We might have to talk more about that at the end of the episode. That's awesome. Welcome to the show, Raoul. Great to have you.
Thank you so much. Great to be here.
And then our second wonderful guest is Preston Van Loon. As I say, another co-founder of Prismatic Labs. His pronouns are he, him. Preston is an impact-driven software engineer, a blockchain enthusiast, and an avid aviator. Again, something I want to chat more about. Like Raoul, Preston also dropped out of university to start his journey of self-learning in computer science and software engineering. Prior to forming Prismatic Labs, Preston was working at Google while moonlighting an obsession with Ethereum's protocol and scaling efforts. Preston left Google at the end of 2018 to work on Ethereum full-time and hasn't looked back since. Lovely to have you, Preston. Very excited.
Yeah, thanks for having me.
So for those of you who don't know me, my name's Angelica Hill, and I will be hosting this episode. And I'm very, very excited, as this is a topic that I myself have not had a chance to really dive into. So I'm excited to learn a lot along with all of you wonderful listeners and watchers. So I'm going to dive right in. So for the newbies like myself, it would be great if we could just set the groundwork. What is blockchain? And what does it mean to build technical infrastructure for the blockchain? Raul?
Sure, I can take a stab at this one, of course.
Awesome.
Yeah, so at a high level, blockchain is, like people describe it as a distributed ledger technology, right? What this means to me is, imagine if you have thousands and thousands of computers around the world that basically have this shared database, and they're all synchronized with each other, such that if anyone tries to lie about what's in the database, they're not part of the core consensus, and basically they're not treated as the canonical truth. What this allows you to do is it allows you to build a lot of very interesting, really cool applications, especially some that are what we call censorship resistant. So this means that, you would have to basically kill the majority of these computers running this network to try to censor things, right? Makes it especially interesting for places that, have increased state surveillance, or places where people might not have access to technology like this. So to me, that's, I would describe a blockchain in simple terms as something of that sort. And what does it mean to build technical infrastructure for the blockchain itself? Well, of course, the blockchain itself is basically just a collection of servers that are communicating with each other through the open internet. To build something like this, you essentially need to have knowledge of distributed systems. You need to work on database technologies, P2P networking, and you also need to be able to deal with a highly adversarial environment. A blockchain is meant to survive all sorts of attacks and people trying to bring it down. And when you're building software for that, you need to be aware of, how you can prevent against, both malicious attacks and maybe unintentional attacks. So it's everything regarding building servers in a distributed systems adversarial environment. That's what we define as technical infrastructure for blockchain technology.
Awesome. And what is Ethereum? Where does that come in?
Yeah, sure. So Ethereum is a blockchain, and really the key features of Ethereum is that it's not only a place that has its own currency, it has its own token, or however you want to say it. It's run in this distributed fashion all across the world of thousands or hundreds of thousands of machines. And like Raul was saying, it's a really different paradigm where in traditional computer science, you have everything kind of run in your control, or you really understand it. And here we're in this totally different network. So what Ethereum's key feature is that it's an application platform. So not only are we agreeing, all of these anonymous actors are agreeing on the state of the distributed ledger, but they're also agreeing on the state of the world after executing pieces of arbitrary code. So with that, you're able to deploy what we call these decentralized applications, or dApps, which you can't really do this in any other place where you have this truly trustless environment that you can build these types of applications.
Yeah, I want to add on to that. It's basically like this global shared computer kind of that anyone can use, right? Instead of deploying code to some server on AWS, you can deploy code to kind of this platform. And by nature, your code is pretty much unstoppable, decentralized. Once you put it out there, it's hard to take it out. It's hard to stop it. And there are a lot of different reasons why you might want to do that. And there are a lot of reasons why you might not want to do that. So I think that, we'll get into that a little bit more, but, there are some use cases that are really great for this and some use cases that might fit the traditional centralized paradigm a little bit more.
So when you were kind of starting to look into blockchain and getting excited about kind of cryptocurrency and this area and thinking about moving into the space, and you creating, Prismatic Labs, why did you settle on Ethereum? Did you think about other avenues to investigate? I'm really interested in kind of how did all your ideas, your interests come together and form what you have now?
Definitely. I think Preston and I would consider ourselves pretty pragmatic engineers. So when we first started on this journey, we were just excited by this concept of having this global computation platform that anyone can use. It was like, wow, so cool. What are the things that this can enable for the world? And, of course, blockchain and cryptocurrency has had quite a negative reputation on a lot of fronts, especially because there have been a lot of nefarious use cases for the technology. And you can say that about any sort of new technology, right? Why we got excited about Ethereum is because, Bitcoin was, of course, the first blockchain, the original blockchain, and it serves its use case as basically a store of value. Basically, the predominant narrative is that Bitcoin is like this digital gold, right? But on Bitcoin, interestingly enough, you can't really like run code or run these decentralized applications that are Turing complete. So, you can't like write a custom, piece of software that basically can do whatever you want. Ethereum is the first blockchain actually that allows for these decentralized applications, for basically decentralized computation of software. And to us, that was really cool. Ethereum has the most network effect, has the most developers, the most people building on it. It's not controlled by a single company or a single person. People say like it has a soul. It's basically community owned, and that to us is really awesome. That's kind of like why we got into it.
Yeah, Ethereum, like one of the big motivators for us was the community, because we kind of discovered Ethereum independently. Raul and I had never met before, and kind of both were in the same, phase in our like life journey of figuring out what do we want to do in our lives. And we discovered Ethereum, which has this like incredible potential to have high impact on global society and really enable and empower lots of different groups of people. And when we said, hey, we want to get involved with the open source project that is Ethereum, we were met with basically open arms. And that was just like, personally had never experienced anything like that. Just such an amazing community within the Ethereum ecosystem.
Yeah. And I guess before we go a little bit deeper, I guess it would be great to talk, we've been chatting about, what this can do for the world, like, how cool it is, what it can enable. Maybe we can chat a little bit more about what exactly Ethereum enables that gets us so excited. From my perspective, Ethereum enables two major things. And these are not real words, but basically one of them is permissionlessness. So permissionlessness is, basically means that there are no gatekeepers. There's nobody telling you that, you cannot do this because, you're not allowed to. It's this global platform that you can use really for anything you wish. And an example may be access to financial services, right? So being able to take a collateralized loan is a luxury that a lot of people in the developing world might not even, have access to, might not even be approved by their bank or even by their country. So permissionlessness enables a very interesting set of tools, that provides options to the world. The second thing that Ethereum enables, another made-up word, is trustlessness. So trustlessness means you don't need to kind of like trust any intermediary, any third party about basically interacting with this platform. There's no middleman, there's no company in control that can change the outcome for you and change the rules. So we think these are very pivotal features of blockchain technology and pivotal things that Ethereum enables for applications built on top of it.
I mean, working in this space, though, just to take the counter to that, like, have you encountered risks? Are there downsides? I mean, my gut reaction is this sounds wonderful, but having no moderation, having no kind of rules kind of makes me second guess a little bit and go, oh, what are the risks there? So interested to hear kind of the flip side of that, and maybe a little bit about how you keep that top of mind to mitigate these kind of risks.
I think the amazing part about this technology is that while there are no rules, you really get your opportunity to define those rules. So you're able to develop what are called smart contracts, or these decentralized applications, which are everyone can read them and understand what's going on. What are the constraints of this protocol that you've launched on Ethereum? And if you're talking about, true like decentralization, there are these concepts where you can have what's called a DAO, DAO, or decentralized autonomous organization, which is a group of, anonymous people that have voting rights in a protocol and are able to make the upgrades and change the rules. With Ethereum or really any blockchain, it's like a write once and read many time kind of style database. And you're not able to remove or delete or change anything unless that's part of the code that you've written. And as a participant or user in your protocol, I can see that and I can base my risk assessment. Do I want to be part of this application? I can read the code and find out for myself.
Yeah, we can give an example maybe for listeners of an application that is possible on Ethereum that would not really fly in the traditional world. So let's say that I'm trying to build a lottery startup. Like, okay, you give me money and then every week I'm going to decide a winner, right? Let's say that you're just a regular software engineer, you want to build this, right? If you put up a website right now and you tell people to put in their credit card and trust me, I'm going to decide the fair winner of the lottery every week, would you trust that website? Probably not. On Ethereum, you can read the code and it's all public and verifiable on the blockchain of the application you're interacting with. So I can actually read the code of the lottery application and check that, it actually is a decently fair lottery. I'm not going to get basically rug pulled by the creator of the contract.
You'd also be able to see that there's actually a prize at the end, right? You know, like some lotteries are like, hey, buy into my raffle, and there's nothing there.
Yeah, you might never know if anyone won because you put trust that someone must have.
Right. So that satisfies the trustlessness property that we so value in this platform.
So I want to now turn over to the fact that your project is entirely written in Go. Hence why we're talking about this on Go Time. So interested in how you decided to go with Go. Like, where did that come from? Was that a decision you took? Was it something that was community-based? Love to hear about the process there.
Preston, maybe do you want to go over what our project is exactly, maybe? And then we can answer that one.
Yeah, I'll take the first part of that. So our project is basically, we have written a client to the Ethereum blockchain. This is how you interact and participate in the system. Everyone interfaces with the client in some form or fashion if they're interacting with the blockchain. And we have written it entirely in Go. We've really enjoyed that part of it. And the primary focus of building this kind of thing is we want to help Ethereum scale. And what it does is help secure the network, helps users interface with it, and in general is the backbone of how to interact with the blockchain. Ro, if you want to answer, like, why did we go with Go? That'd be great.
Sure. Absolutely. So, to get a little bit more technical here. So Ethereum today, it's been running for many years, actually. And the most popular implementation of Ethereum, the actual node software the person is talking about, is a project called Go Ethereum, which is written in Go. It's one of the most popular Go repositories on GitHub. Ethereum is actually upgrading its infrastructure and upgrading the way the protocol itself works to be more scalable and secure. And to do this, basically, it's a pretty big rewrite of the whole protocol itself. So our implementation is a separate project, and it's called Prism, and we are basically revamping Ethereum, and we're doing it in Go. Go has been proven to work for Ethereum. The concurrency support is critical for an application like this. A single blockchain node does so many things at once. It's dealing with incoming peer-to-peer connections. It's dealing with processing of very high-intensity data. It's constantly under interaction from users, from API requests. So there's a lot of things going on, and Go just provides a really simple framework for us to build something that is maintainable, is testable, and gives us the benefits of concurrency, which are critical in this sort of application.
And coming into this project, were you using Go previously? Was this your first interaction with Go? Interested to hear was it also partly because you had experience with it and knew the kind of core benefits of Go as a language?
I think for each of us on the team when we started had a different personal motivation for using Go. For myself, it was a learning opportunity. I had been at Google, and when I joined Google, that was sort of one of the things I wanted to explore was using the Go programming language. I thought it was really exciting, cool technology. As things go, when you get hired, these things, you're not always using the language or technology you want. I was working in ads and working on Java, which I'm not particularly excited about, but I wasn't going to say no to Google, So just before my journey of Ethereum, I had been learning Go, and I took a course from someone called Bill Kennedy. I think he's been on the show a couple times. Yeah. And it was like a 2-day session of learning all the basics of Go, and it was like a $10 thing. And I couldn't believe it. It was one of the things that set me off on my journey with Go. And Bill, if you're listening, thanks for that. I'm not sure if you remember, but that had a big impact on why I chose Go and my journey there.
And when diving into development, was the use of Go what you expected? Were there any surprises, any pain points that came about after you had already committed to using Go?
Absolutely. I know that generics are probably going to be the first thing that come up.
Yeah. I wasn't going to bring it up, but
you're going to bring it up. We've had a lot of cases where we really push the limits of some of the things that Go does. In particular, there are a lot of interesting challenges when you deal with writing blockchain infrastructure in Go. I would say, namely, you have to really be prepared for upgradability and making sure that you use the right abstractions. So an example is, there's this data structure that we call the state. It's basically this giant data structure that keeps track of, a lot of things happening in the entire universe of the Ethereum blockchain. And the blockchain advances via deterministic state transition. So the state is modified by an incoming structure called a block, and then you get a new state. So you get a post state. Mm-hmm. And, the state, it needs to be upgradable. So say that tomorrow, or, everyone agrees that, hey, maybe in a year we should upgrade this data structure to be a little bit different, right? It's not as easy as in traditional software where you can just upgrade everyone. You just do a software upgrade, right? It's a distributed system, meaning that once it's out there in the world, like once you have a rocket out in space, you can't just be like, hey, let's change some of the parts, right? Mm-hmm. You need to make sure that there's a migration strategy. You need to make sure that it upgrades properly. And to do this, you need to have very good abstractions, leverage interfaces really well. You need to leverage, just like get around the lack of generics by finding a good balance of either code generation or also duplication of important logic. Something else that has been really important for us and something that's been interesting usage of Go is that it's very easy for a big project like this for developers to kind of like shoot themselves in the foot because there's so many moving parts, right? And if you don't set the right abstractions, somebody could get hurt. So an example was that we had this database accessor previously where you could basically retrieve data from the database. You could also write data to the database, right? It will be something like save state, get state, Mm-hmm. We soon realized that having this interface that allows for state writing is very dangerous because new developers can just use this interface and like, oh, let me use this interface. And it's fine if I write to the state, right? But it should not be fine. So we've been really leveraging, composable interfaces, making sure that we expose as little as possible to developers that might interact with the code in dangerous ways. So we think it's been really interesting, and there's a lot more that we can get into that. Overall, our usage of Go has evolved to fit the security requirements of the application a lot more.
And kind of going off of that in the realm of like security concerns, in terms of like for your employees, for people who are contributing to the open source, like are there guidelines you ask people to follow? Like how do you keep security top of mind when you're moving forward, when you're continuing to develop? I mean, this might just be my impression, but I feel like security in this realm is extremely important, but also an area that I'm sure you get a lot of kind of hacking, phishing, this kind of thing. Would love to hear more about that and how you kind of keep that top of mind, as I say.
Yeah, I think that with a lot of the changes that we see going in with Prism is that they have to be reviewed with a high level of scrutiny. You're looking at, specifically what is it doing in its context, but also how is this code path involved in the greater aspect of the system. Mm-hmm. There are many times where you're just, using a piece of code with a certain set of assumptions. And if you're not really thinking about, what could happen or what are ways that this could potentially be misused, either intentionally or unintentionally, that you might let slip through things that could be undesirable. And that's either like just a performance bottleneck maybe, or something that in an adversarial network like Ethereum that an attacker could take advantage of. So it's something we always have to think about. And when we're looking at code review is a huge part of our workflow. We always make sure that everything's been reviewed at least by one extra person. And when we have new contributors come on, there's an extra set of scrutiny with those types of changes.
Yeah. And Angelica, I think you also mentioned probably security concerns for the employees themselves,
yeah.
Right? So that's also an interesting question. So it's a system, of course, there's a lot of money at stake in the system, right? And basically somebody could argue like, hey, what if somebody comes and like threatens the developers to add a particular like change that might be subtle, but could be very dangerous and risky. Mm-hmm. The benefit of a system like Ethereum is that the development is sufficiently decentralized such that, like single points of failure are not as prominent. So if there were like one developer, one maintainer, and one implementation that everyone used, right, then it could be very easy for that person to change the rules. But even if that developer went malicious and went rogue and tried to introduce some malicious code into the repo, of course, users are savvy, people are savvy, everyone has a choice of the software they want to run. If that's the case, then social consensus would just basically, fork the project and basically maintain it on its own. Thankfully, we're not the only people writing the code for this major upgrade to Ethereum. There are 3 other implementations in production today, and they have very capable teams that are working on this alongside ourselves. So, I'd say the responsibility is definitely it's spread a lot more than if it was just, like Preston and I, for example, like pushing a button that could basically affect everyone.
We don't have any unilateral permissions or something like that. We're just like any other user of the blockchain. The things that we're, mostly concerned about are how can this code be compromised, but we don't have any special access or anything like that. And that's just how the protocol was designed. You can't trust anybody, not even, yourself or like the team that produces it,
Yeah, exactly. One other thing I would like to add too is, like writing software for this is very tricky, especially compared to like traditional software engineering that is probably hosted on your own servers under control. The security, basically like the security profile is quite different. Like when you're writing a traditional server-based application that is typically, maybe a company backend, right? You don't have to think like, what happens if say you have this file, this Go file, and you're like, what happens if an attacker makes it past line 5 or line 6 or line 7 of this file? Like, every line of code basically is a line of defense against attacks. And when you write code like this, you cannot let anything slip, right? Like anything, even like, especially like say like nil pointer exceptions, panics, anything of that sort can absolutely be devastating, because not only can it be exploited by accident, maybe like it just happens in the code path by accident, but it could be exploited by a malicious attacker for no cost, right? So one of the things that we think about a lot is, what is the trade-off? Is this a cheap attack to execute if somebody could exploit this? If not, then, should we worry about it as much? There are a lot of mental models that you can use, but it is quite scary. And you do need a particular defensive programming mindset for even the smallest lines of code committed to the repo.
This episode is brought to you by our friends at LaunchDarkly. Feature management for the modern enterprise. Power testing in production at any scale. Here's how it works. LaunchDarkly enables development teams and operation teams to deploy code at any time, even if a feature isn't ready to be released to users. Wrapping code with feature flags gives you the safety to test new features and infrastructure in your production environments without impacting the wrong end users. When you're ready to release more widely, update the flag status, and the changes are made instantaneously by the real-time streaming architecture. Eliminate risk, deliver value, get started for free today at launchdarkly.com. Again, launchdarkly.com.
So in terms of someone coming to this project new, how do you teach them that defensive mindset? Like, what are the things that you would encourage people who maybe are more new to this space but want to get involved to keep in mind? I.e., how do you change your software engineering mindset when writing code for a project such as yours?
Yeah, it's a great question. I mean, it's really about like threat modeling and understanding what the code is intended to do, but thinking about ways that it may be misused. So some of the common pitfalls are like, overflowing of values. Like if you're exceeding, in Ethereum, we deal with some very large numbers where you might easily exceed a 64-bit number, or maybe you're using some floating point number as well, which loses a bit of precision. And when you're talking about a blockchain network where everyone has to agree on everything all the time, it's extremely important that you got it right in every implementation and it behaves exactly the same. Yeah, I mean, it's a lot of the things that I think security engineers think about when they're looking at any kind of system, but especially the risks, or I guess the consequences, are higher, it feels like, in blockchain, especially because it's so difficult to fix something once you've discovered it and it's already out there. It's kind of a race between you, the attacker, if there is one, if it's exploitable, and then asking thousands of anonymous people that you don't know how to contact to please update your software, without at the same time telling the attacker, like, look at this, here's a big bug that's exploitable right now. It's really like weird space to have to think about that. So then we think about with everything we do, even some of the most like innocent code, we're still trying to think like what could happen with this,
Yeah, it definitely depends, because there are definitely different tiers of changes, right? Like we recommend contributors, of course, to always try to find, what are tagged as good first issues or initial places to help. A lot of those, of course, if something goes wrong, it's not gonna kill the system. There are different tiers of threats, right? The worst thing that I would consider, one of the worst things that could happen is what we call a chain split. So a chain split is there's a consensus failure, meaning that like you have thousands of nodes in the world and like 50% of the nodes have a bug that makes them disagree with the rest or something. And then nobody agrees on anything. And then, how do you fix that, right? You need to have some sort of social consensus on what is a canonical chain. So that's our worst nightmare. having a chain split, because that's like, reduces legitimacy a lot of the network, and it can cause a lot of harm in the short term while it's maybe being resolved. So a lot of those things can happen because, like we said, Ethereum is a protocol. So there's a specification, and the specification is basically like any specification. It's a blueprint. You're free to implement it however you wish, as long as you meet the criteria. If, for example, when our node, which is written in Go, is interacting with another implementation, which is written in Rust, and there's a small, disagreement in like a state transition function that causes a different result, then you can have a chain split. So those types of changes, of course, like require extreme scrutiny, anything that touches that part of the code. But a lot of other things that are, more like implementation specific, things like that, I'd say like the threat model is different.
So I'd love to hear, what happens when things go wrong? I mean, have you had instances where things have just blown up and it's been critical? I'd love to hear kind of, it's great that you put all these things in place to prevent stuff happening, but inevitably, as with all systems, like things go wrong. So what happens when things go wrong?
Rollo, do you want to answer that one?
Sure. So we've had 2 incidents, actually. One of them was in a testnet. So a testnet is basically a large-scale test of the real thing with like fake money. So people are running it across the world the same way they would run the real thing. But if something goes wrong, that's, it's fine. It's a place where things should break and we should test things out. So we've had a really serious incident in the testnet where, we learned about the perils of how to deal with community engagement in times of problems. So what happened was, we had a very innocent assumption that ended up being a really terrible assumption in our code. Ethereum is, our software in particular, is a synchronous protocol, meaning that time plays a very big role in this. Basically, every 12 seconds, there's somebody in the world that needs to produce the next block in the chain, right? So basically, everyone has to have a pretty good sense of computer time for the system to work properly. We had the assumption that, hey, if people's clocks are out of sync, maybe we can help them adjust it using something like a Cloudflare NTP servers, right? By doing this, actually, Cloudflare had a bug in which they were reporting that the correct time was around 6 hours in the future. So everyone's clocks that were running our software got their clocks completely out of whack. It was a huge mess. The issue actually ended up resolving itself. But here's what happened. We actually ended up making it a lot worse because we told everyone like, hey, turn off your node, right? Or upgrade your software. And then you have like all these thousands of nodes turning off at the same time, trying to sync with each other. And, you have this peer-to-peer network where you're basically like one good fish in a pool of like, sharks. And for every good node that is serving good data, you have like 20 or 30 nodes that are serving you bad data. So it became almost impossible for any node to synchronize with the state of the chain. So, we learned a lot of lessons there. Really, it's like about how you communicate, how you fix something like this, right? Like we said, it's like trying to do like a product recall for something physical where it's already out there in the world and you can't really bring it back to your factory. So that was a really interesting learning experience, and that really helped us analyze all the assumptions that you make when writing software like this. There cannot be any single points of failure. You need to communicate everything carefully. You need to tell people to not panic. That was a very memorable event that taught us a lot about distributed systems.
Yeah, that one was a very interesting issue. To elaborate on the exact causes, we had this Cloudflare service called Roughtime, where it would take there's a set of actors that would report what time it is. Mm-hmm. And then the code would take the average of that. And one of the reporters was off by 24 hours. So that resulted in the client thinking that, okay, well, my time is off by 4 hours. So it started acting like things were 4 hours in the future. And then, yeah, like Rollo said, we said, all right, everybody update now. But when these clients are talking to each other, when you're talking to a client that is still syncing, it's not helping you propagate good messages. It's sort of just still holding onto them because it's not sure whether or not those are good or not. And yeah, we really learned to like take your time with these kind of things. Like, don't make the problem worse. So we definitely made it worse that time. And this came in handy when we had a real issue in the main network where there was actual money at stake. Mm-hmm. We had this issue where basically all of the Prism clients, this is our client written in Go, was agreeing with data without actually verifying some portion of it. And there was a second bug that was producing some invalid data. And so one bug was made drastically big by a second bug, and these two things together made this really weird situation where Prism would fail to produce blocks because it couldn't execute this transition, over several hours, and it happened twice in one day. We were able to really sit down and take our experiences from all the practice we've had, and I think it took us 30 hours consistently working on it before we were able to produce a release. But we were really glad that we were able to have that experience of like going through this type of situation where there's not real money at stake, and kind of thinking about what do you do when things don't go right in a blockchain, because it's a completely different paradigm of like, all right, well, I'll push this button in our fleet of servers will update in 30 minutes and everyone will be on the same piece of code. It's not like that. You have to consider how are things going to work when you have mixed versions and you can't contact everybody and everyone's on different time zones and some people aren't even paying attention. So yeah, it's really interesting.
Yeah, and to quantify, I guess just the value of this, right? So to participate in consensus, consensus means that you are running a node that is able to produce data for the blockchain that can then basically advance the state of the chain. To do this, you have to put what we call a stake. You have to stake a significant amount of capital in the form of a token called ETH, which is the native currency of the Ethereum blockchain. Mm-hmm. So you have to stake 32 Ether, which, if I recall correctly, maybe last week or something, went up to a crazy high amount to something like $110,000 or more. And to give an idea, how much money is at stake in the network, somewhere around $15 to $19 billion, some unimaginable number. And the incident exposed that Prism runs around 74 or 75%. Sorry, it's over 2/3, but somewhere around that of the whole network, right? So there's a lot at stake. A lot of people are depending on software like this. So we had to take our time.
So I'm interested in, how do you test your code? What is the process of testing? Is there regression testing? Do you have unit tests? How do you ensure before you push into, actual production, the real world, that this code is good to go?
We have many layers of testing. The first obvious one is the unit testing, keeping things tested in small isolation. We have fuzz testing. We have what are called spec tests, which are basically conformance tests that are produced by the reference. We have a reference implementation, and all of the different client implementers can download these tests. It basically says, with these inputs, you should expect this output. Mm-hmm. We run all of those. We run full end-to-end testing. Most of these things are done in code pre-submit. So actually, if you're proposing a change, we'll run the change through simulation for about 10 minutes. And basically, it's a smoke test to see, does the world continue with your change, or does it blow up? That's a great way to stop really, really easy bugs that way. And then we have a pretty long process of pre-production soak. So with our software, we put it out into the test network where there's no real money at stake, but there is an environment that's very close to simulation of the real world. And we'll run it there for, some medium-term amount of time and be able to check, okay, well, is there performance regressions or new logs that are appearing or anything kind of weird that would be concerning for this kind of release? And we call that the pre-production soak. And we also do canary testing on top of that.
So in terms of thinking about the state of your project currently and where you hope it will go in the future, I'd love to hear a little bit about what is the vision? In the world of Ethereum, as well as kind of your specific project. What's next? What are you excited about? What are you thinking about at the moment?
Sure. So, our company is fairly unorthodox, I would say. We started this just because we really saw the promise of Ethereum, and the way, we didn't talk about this, but the way that we are funded is we are funded through a generous pool of grants and donations, particularly from organizations such as the Ethereum Foundation, which is a nonprofit that kind of started the Ethereum project and now has been taking a step back given the increasing decentralization of the project. They have a lot less influence, but the Ethereum Foundation is always basically helping with funding, with support, with research, with anything that's needed to kind of help push the envelope. Of course, grants are not sustainable revenue for a company. So one of the things that we're very much excited about is, we want to fulfill the promise of upgrading Ethereum to a scalable and more secure version. Beyond that, we want to basically produce tools and services that will further add value to people participating in Ethereum. These are still kind of in the pipeline and we're still working through them, but yeah, we're excited to unveil some of these.
I know this kind of project came out of your interest. You both were excited. You came together serendipitously through the community. I mean, is this now the space that you want to live your software engineering future in? Is this your forever project? Or are there areas, whether within this kind of broader blockchain world, that you'd like want to look into as a side project? I'm just interested in, or twofold. One, individually, are you able to do kind of side projects? This seems like a very kind of time-intensive project to maintain, especially given the kind of, as you said, the very careful review process, testing process for any changes. But just in this space, like, are you able to interact in various different areas, or is it really one where you have to choose? Like, Ethereum is the one I'm going to go down. I can't really think about the other ones other than maybe reading about them or being interested in them.
I think that Ethereum has a lot of really unique computer science challenges. Mm-hmm. It's a very different world from like web application development, or really a lot of more common software engineering roles. Mm-hmm. That's kind of what attracted me to it originally. I feel like that even though we do spend a lot of time working on Prism and the scaling effort, this is very important to us and for the Ethereum community to help make Ethereum a thing and be like a global asset or something that everyone can use. I do find value still in continuing your self-learning. So that may be experimenting at the application layer. That helps you understand who are our users. You know, our users for Prism are sometimes application developers or people running the software, the operators. So it's always helpful to like get in there, see what pain points they're having, and that might help you come up with an idea that we can incorporate into the project. There are a lot of different blockchains out there that are kind of have a similar goal and using a lot of similar strategies. So I do find it helpful to occasionally look into those projects and kind of understand what trade-offs do they make to come to the conclusions that sort of we're all trying to get to. It's definitely valuable to do that from time to time.
Yeah, and we're all full-time at Prismatic Labs, so we have nine members on our team, and we're looking to keep expanding our team. So like Preston said, there's so many really cool challenges, right? And I think I really urge listeners to kind of dig deeper into this. Some really cool innovations happening in cryptography, for example. The way that Ethereum and kind of like the blockchain that we're building is able to work is thanks to some really novel innovations in cryptography. In particular, we want to make this blockchain as decentralized as possible, and meaning that a lot of people can participate. Anyone can run on a computer across the world. And to do this, you need to make sure that basically cryptographic signature verification can be done at a massive scale. This means that when somebody broadcasts a message on the blockchain, it can be verified. It can be done efficiently, right? So Ethereum uses this really cool technology. Our project is called BLS cryptography, and it basically allows for aggregation and mass verification of cryptographic signatures in really efficient ways. So that's just one example. There's some really interesting things happening around game theory, right? Like, how do you create incentives in this decentralized environment? Adversarial thinking, security engineering, P2P networking, right? Like, basically, you have all these kind of, like pseudo-orthogonal fields just colliding and coming into this one place. So I think that if Prism keeps evolving, if our project keeps evolving over many, many years, then I think that we failed. Basically, Ethereum needs to ossify. It needs to basically finish its upgrades, be done, and basically be settled, right? So we're excited to kind of finish that. And basically our software will then move into maintenance mode, where basically, you're just maintaining, improving things, but there are no massive upgrades to the system. For Ethereum to work, it needs to be stable. It needs to be, it needs to be predictable. And, we're working towards that over the next 2 years.
And in terms of in general in the blockchain space, is it a competitive market? i.e., is it like Ethereum versus the others? Or is it kind of the innovations that you are making can be kind of taken and applied in other ways, obviously in other areas? I'm interested in just like, is it like we want to make Ethereum the one, or is it that they can coexist?
That's a question that a lot of people are debating right now. But
yeah.
It's like, me personally, I think that Ethereum is really well positioned to continue to be a dominant player in the space where there's a potential for multiple implementations or protocols that do a decentralized application platform. I wouldn't say that there's, room for just one. In the crypto space, we call this maximalism, where it's like only my thing and nothing else kind of deal. Where a lot of like people who are building on Ethereum or next to Ethereum were more like building bridges and helping bring these different types of technologies together, because they each make different trade-offs. They each are trying to solve problems in a specific niche of a certain market sometimes. And it doesn't have to be just a single platform. It could be multiple. Some of them are privacy focused, some of them are speed focused and other things. But Ethereum, I think, is definitely the most well positioned for it.
Yeah, network effects are very strong, and that's very important, right? Like, you can create a blockchain today, right, by like maybe forking a popular one, but if you don't have any users, you don't have anyone to transact with, like, why would I use it, right? It's the same conundrum that like messenger apps have, right? What's the point of creating a messenger app where you're the only user, right? So a lot of projects are trying to grow by like either trying to spend a lot of money to gain a larger user base, either like sponsoring people to build on their blockchain and trying to do all these different things. A lot of the competition seems to be around like a lot of metrics, like transactions per second. Like, oh, look, our blockchain can do 1 million transactions more than Ethereum can per second. It's so cool, so like come to us, right? But the reality is that Ethereum, even though, it's been going on for quite a few years, it is quite limited as it stands today in terms of transaction. It has a pretty big network effect. A lot of people are using it. A lot of people are depending on it. Applications are built on it. So, whether the network effects will hold or not, or people will migrate to another one, there's a better technology and people like it, then that's great. We really believe in it because we think that it offers the best compromise towards decentralization, security, and also scalability. And it also has a community that is very, grassroots, very homegrown. Like people just are using it because they think it's really cool, right? People weren't paid to kind of build on it. And I think that's really special.
So is that how you grew kind of when you were launching your project? You kind of already had an existing community to build upon? Like how did you grow the usage of your project?
Good question. So our project is fairly unique in the regard. So, we're not an application. We are basically an implementation of the Ethereum, what's called the Ethereum 2.0 specification. Mm-hmm. So, essentially the whole community has been excited for Ethereum to upgrade. There are a lot of things that are in the pipeline, such as improvements to security and scalability. And we were one of the first people to start working on these upgrades. And, since people are very familiar with Go Ethereum written in Go, they're also pretty easy to onboard into using our software, which is also written in Go, shares a lot of tooling and a lot of similar functionality. So, thankfully, like a lot of people gave us a chance and started testing our software early on.
This episode is brought to you by Linode. Gone are the days when Amazon Web Services was the only cloud provider in town. Linode stands tall to offer cloud computing developers trust, easily deploy cloud compute, storage, and networking in seconds with a full-featured API, CLI, and cloud manager with a user-friendly interface. Whether you're working on a personal project or managing your enterprise's infrastructure, Linode has the pricing, scale, and support you need to launch and scale in the cloud. Get started with $100 in free credit at linode.com/changelog. Again, linode.com/changelog.
I'm very excited. This sounds all very, very cool. But as I say, as someone who's very new to this space, what are the things that I would need to do to bring me from my current newbieism to being a contributor to your project? Like, how do I become a contributor?
So the Prism project is fully open source on GitHub. We tried to do all of our stuff in a transparent manner. So that's either like posting updates, talking in public channels. We have a Discord community of about 10,000 people. So there's a pretty big community there. If you're looking to come with basic questions, that's a great place to get answers. But really, checking out the project, running the code, trying it in a test network, and really just like, if you look at it and you're like, oh, this doesn't make sense to me, why is it this way? That kind of feedback has been extremely valuable for us. And as a contributor, you could say like, all right, well, this has some friction and I have an idea to fix it. And you can propose that change. And most of the time, almost every time, we'll take that and say, this is a great perspective and feedback and help get that merged into the project.
Yeah, I would say for people wanting to just kind of learn more and get involved, right? So I would recommend the Ethereum website. Ethereum.org is a really great resource. It's like this open source resource that has all sorts of very amazing information about kind of what Ethereum is, what are the things that it enables, what are the things that you can build on it, right? And kind of like what's happening to Ethereum in the next year or two. And what's happening is there's this massive upgrade called Ethereum 2.0, which we're working on. So once kind of like you get into it and you read more about it, you learn more about what's coming, you might want to try running a node, like Preston said. So running a node in the testnet is a really great way. We have a documentation portal. There's a lot of stuff written about how to set up a node, and you can try even building it from source and try to do it yourself. And that's really cool because then you can start asking questions, like Preston said, like, why does it do this? Or like, why does it use so much memory and RAM? Or like, what's going on? And you start digging deeper and asking questions. And really, like, a lot of our team actually has joined us organically because we have this Discord community, this Discord server where we talk to all of our user base. And some people come in, just are trying to run a node. They're like, hey, like, why is this way? And eventually a lot of those people ended up joining our team full time, right? I think that was really cool. It's really an open field for the curious mind. And all of that is available. And there's very helpful people willing to just answer your questions.
So in terms of kind of coming to the project with kind of a software engineering background, but like very typical, no security background, no cryptography, like all of that, that's kind of, it is accessible? Or would you recommend that kind of side note, you go and kind of learn a bit, read a bit, get up to scrap on that before diving into an open source project such as yours? Or is it truly like through the documentation you've mentioned, it is truly kind of something you can kind of self-starter?
You could look at the specification, documentation, kind of get a rough understanding. I think that a lot of people, there is a bit of a learning curve because of the volume of information that you have to understand before you can make meaningful, large contributions to such a project. Especially if you're coming from like traditional computer science, software engineering background, and then trying to do something in blockchain. It's like really interesting in that way, but it is a lot of information to learn before.
Be prepared to have that steep learning curve.
Yep. Yeah, it's like an uphill climb, but then a downhill ride. Once you figure it out, you're like, wow, this is really fun. And you're just cruising along.
Raul, you going to add something?
Oh yeah, no, that's such a fun part, like as you're learning, right, as you're asking questions, you really get a feel for kind of like what this involves, right? And yeah, contributions can range from really anything from, as small as improvements to like, structure or readability, or all the way to like non-trivial features. And like, we'll be more than willing to help contributors on that front. I think that's something that has helped us out a lot. Actually, some non-trivial features have been written by contributors that are in production today, running a lot of money at stake in the network.
So the conclusion is that you can do it. Just persevere on that upward climb.
Anyone can do it. Yeah, we call like kind of the work that we do, we call it core development. So core development is kind of like the core protocol is like, the underlying foundations of how this stuff works, right? It's like kind of working on the operating system of your computer, right? So we have the perspective that anyone can be a core developer. Seriously, anyone. All it takes is asking questions. And there's never been a better time. People are willing to help and answer questions and guide you. So yeah, it can be intimidating, but it was also intimidating for us when we looked at some of this stuff a few years ago.
No, for sure. Well, I think that the takeaway is this is so cool and super interesting, and you can do it. I'm now going to switch gears, and we are going to jump into our unpopular opinions section, which is a staple of our wonderful Go Time podcast.
I actually think you should probably leave.
As I've mentioned, your unpopular opinion can be about anything. It does not need to be about blockchain or software engineering. It can be about food. We had someone say they didn't like chocolate a few weeks ago, which was quite controversial.
Oh, man.
So I'm going to pass it over to you, Preston, first. What is your unpopular opinion?
So this is an unpopular opinion that Raul and I actually share. And we really dislike food with bones. So like chicken wings or like
especially pizza
with bones is just ridiculous. But really, like if it has bones, or like I just wish I didn't see that. Like I know that meat and stuff. The animals have bones, but I don't want to know about it. It's just kind of like a weird like mental thing.
I'm gonna hope you were joking about the pizza with bones, or did people actually put like chicken wings on pizzas? I'm a vegetarian, like I don't touch meat, so this is a new phenomenon to me.
You'd be surprised.
Okay. I'm feeling very like I made the right decision to stay away from the chicken wing pizza.
Yeah, no bones in the pizza. That's I guess that's a popular opinion, but I mean in general, like we kind of take it to the extreme. Like if it has bones, but I don't want that.
You just don't want to see it.
Yeah.
I feel like that is an unpopular opinion. I'm sure there are many people who love I know like things like ribs, like off the bone. Many of my friends love that. So we'll see how that trends. Raul, what is your unpopular opinion?
Mine is that I'd say like most like modern video game music is much better than I guess like popular music.
Okay.
So that's my unpopular opinion.
Video
really
game
amazing
music is better than pop music. Wait, yes, pop music correct. Specifically as a genre, or
no? I would
like
say
mainstream music in general.
I would say mainstream modern popular music.
What? Why is that? Is it just that you listen to? Do you just play an inordinate amount of video games?
Good question. I think there's a lot of thought just like put into like the emotion, like the environment, the ambiance of like, you know, like it's just putting you in the zone. And I think like a lot of this music does a really great job at it. So, yep.
I don't know whether you've seen, was it Mortal Kombat, the movie? I was obsessed with it, and that soundtrack was amazing. It made me, having not played Mortal Kombat previously, I then had to play it.
Yeah, see, it hyped you up.
Yeah, it did. So, it definitely did. I'm not sure whether that will be an unpopular opinion or not. We'll see. I mean, is it? Do you listen to popular music?
Yeah, a decent amount. I think.
A decent amount.
But I just think that video game music can be more deliberate about making you feel things than what we hear mostly on the radio. So that's my unpopular opinion.
Fair enough. Would you agree, Preston, with you share that one also, as well as the boneless meat or food opinion?
Yeah, I think so. I think, there's a little bit more thought into this video game kind of music. Like Carella said, it's like kind of trying to convey a certain environment. And I guess especially when you're trying to focus on something, those kind of music can help you or get you hyped up or like, I don't know. Yeah, I think I agree with that one.
Awesome. I think those are both, I'm intrigued to see whether those are truly unpopular opinions or not, which I feel like some of the opinions we've had have been kind of not quite as unpopular as I thought they would be. So we'll see. It's been an absolute pleasure. Before we kind of wrap up, I'd love to hear, is there anything else that you'd like to kind of let our listeners know about your project, how to get involved, any kind of things to look out for? Are there any kind of big updates that we should be keeping an eye out for in the Go community?
Indeed. So as it stands today, Ethereum actually runs on what we call proof of work. So people have probably heard about mining, like cryptocurrency mining, like bad for the environment, you know, killing trees, all sorts of things, right? So basically, the way that Ethereum and Bitcoin work today is they require people around the world to like basically run these machines that are specialized computation circuits that use an extreme amount of electricity to basically solve this like brute force math problem and basically participate in consensus of the blockchain. You know, it's basically, you know, the paradigm is that you're putting in a lot of real world electrical power into the system such that it becomes almost impossible that anyone can collectively try to revert that, right? Like you cannot revert like the Bitcoin or the Ethereum blockchain without having more electrical power than all these people combined that put their effort into it, right? So Ethereum is actually migrating to what we call proof of stake. So instead of spending a lot of electricity, what you're doing is that you're instead locking up a lot of Ether. You're locking up a lot of this cryptocurrency called ETH. And basically, to participate in consensus, you need to put that up for stake. If you do anything malicious, you can start losing that stake. It changes the paradigm, right? You don't need this crazy computational thing. It's just basically anyone can run it on a home server. You can run it on consumer laptop, right? You know, since Ethereum was already proof of work, the transition into proof of stake, it's very solid because we can leverage all the security that Ethereum has already over the years into this new paradigm. So We are one of the teams that's building proof of stake for Ethereum. Ethereum proof of work, the mining basically, is planned to go away in less than a year. So, basically no more shortage of GPUs on the market. You'll be seeing a lot of really cool stuff happening. Estimated, I believe, to be like 99.98% more like computationally effective and like better for the environment. So that's something we're excited about, and just keep an eye out on that.
That is very exciting. As someone who bluntly is very, very angry about that, and I do not have any cryptocurrency for that reason.
Yeah.
I mean, is that something that's in theory in terms of that percentage, or is that kind of a ballpark figure that can be kind of, I can hold you accountable to?
No, it's legit. Like you don't need,
awesome.
you can run on your computer, and like that's what we're working on. So So we're working on getting rid of that and getting rid of mining, and we share your sentiment.
Oh, that's awesome. And do you think that's going to be the direction that other projects take? I mean, external to Ethereum? Is that kind of a move that you are seeing across the industry in the space? I mean, obviously, given the recent comments by very prominent figures, i.e. Elon Musk, even before that was top of mind, I know, for many people in the community, is that this is just terrible for the environment. So are you getting that sense that in general in the space, people are going to try and do a similar kind of move?
It definitely feels like less projects are launching with proof of work, and more are using proof of stake or other Sybil resistance mechanisms. That's definitely a concern for a lot of people. And I personally believe that if a project does not switch to something more efficient, then it won't survive long term. So that's
I think it'll be really hard for Bitcoin to switch over. Bitcoin prides itself on kind of being unchangeable, immovable. It's unlikely that they will adopt something as radical as this. They have a very strong perspective that proof of work is the only way to go. For example, we don't share that mindset. The one mindset that I do share, though, is that I think it is risky to launch a proof of stake network from scratch. So proof of stake, like by virtue of its name, you are staking something. You're putting something up at risk that has value that you don't want to lose in order to secure the blockchain, right? If you launch a project with proof of stake and like, where does the value come from? Like, you're staking something that doesn't have any value, and like you're telling me that, like, it's going to go securely. So I'm a lot more skeptical of projects that launch pure proof of stake. I think it can be very dangerous. Like I said, Ethereum is already proof of work for a long time. It already has this massive security pool, and migrating to proof of stake makes sense for Ethereum. So I think there's a trade-off. But yeah, we're working on that.
That's awesome. I'm very excited to see that as it progresses. Well, as I say, thank you so much for joining me today. It's been so interesting. And get ready for me to be pinging you in Go for Slack with many questions I try and dive in. But it's been truly a pleasure. So thank you so much.
Yeah, thank you for having us.
Thank you so much.
If you aren't subscribed to Changelog Weekly, you're missing out on what's moving and shaking in the world of software. We cover what's new, what's interesting, and why. It's totally free. Fight your FOMO at changelog.com/weekly. Subscribe today. And of course, check out the back catalog of awesome episodes at gotime.fm. One of my favorites was episode 156, When Distributed Systems Go Wrong. Go Time is produced by Jared Santo with music by Breakmaster Cylinder. We're brought to you by awesome sponsors. Thanks again to Fastly, LaunchDarkly, and Linode. Next time on Go Time, Matt returns and John too. They are talking Battlesnake and building a game engine in Go. Stay tuned for that. It's coming at you next week.